This video will guide you through the key steps to model a new transmission line and perform line constants calculations in the ASPEN Line Database. The ASPEN Line Database is an electronic depository of data related to power lines and cables with a built-in line constants calculator. If you are new to the ASPEN Line Database, this video is a great resource to help you get started quickly. We will go over how to log into an example database, create a new corridor, create a new line, add new line sections, and produce line constants reports. In this tutorial, we will create a line database model of a 132 kV transmission line that is 45 miles long. For the first 10 miles, this line runs on overhead structures in a shared corridor in parallel next to a 500 kV line. The line continues in a different corridor as an overhead line for 30 miles. The last 5 miles of this line is an underground cable circuit. With this model, we will be able to generate line constants reports, including the line self-impedance and mutual coupling impedance with neighboring lines. Let's get started. The Login dialog box is the first screen that will appear when you launch the line database. To select a database, either enter the file path or click this button to open a file browser for you to select a file. If you are running the ASPEN Line Database Enterprise version, you must also enter your username and password. Contact your database administrator if you do not have the login credentials. We will start by creating the 10-mile span of overhead structures in the existing ZBR corridor, where our new line shares the right-of-way with an existing 500 kV line. Then we will create a new corridor and 30-mile overhead structure where the rest of the line will run. From the toolbar, select the corridor icon. This opens the corridor browser where you can add, edit, or delete corridor data records. Select the corridor you want to edit and click on the Open Corridor button from the browser toolbar. The top panel shows a bird's-eye view of all overhead constructions in the corridor. The bottom panel shows a cross-section of the corridor at a given position in the corridor. To add a new overhead construction to the corridor, click on the Add button. This will open a dialog to select an overhead structure type from the program library for the new construction. We'll select the overhead structure type Equality. Enter the start point of the structure as a distance from the left end of the corridor. Since our line starts from the beginning of the corridor, we will enter 0. Next, specify the endpoint. You can enter this value either as the distance from the left end of the corridor or the length of the construction. If you specify the length of the construction, you'll need to prefix the value with a plus sign. You can specify the horizontal placement offset and the height offset. The height offset you enter here will be applied to the height of all phase and ground wires associated with the selected overhead structure. If the chosen overhead structure has hanging points for ground wires, you need to specify whether they are being used by marking them as connected. You can alter default wire types for the overhead construction, the conductor columns. You can also alter the default catenary sag of the ground wire between towers. Remember, this value must be greater than or equal to 0. We are now done creating this construction. Click OK to add the construction to the corridor and close the dialog. The overhead construction we just created has been added to the corridor, represented by this rectangle in the panel. The construction starts at mile 0 and ends at mile 10. Now we will create a new corridor for the rest of our line. Enter the fields identifying the corridor. The ID must be unique for each corridor in the database. The from and to fields identify the location names of the two ends of the corridor. We can repeat the steps we performed earlier to create new overhead constructions in the new corridor. Since the overhead line section in this corridor is 30 miles long, we'll enter 0 for the starting coordinate and plus 30 for the end coordinate. You should now know the basics of creating a new corridor and adding overhead constructions to a corridor. From the corridor browser, it is also possible to edit, replace, and delete constructions within a corridor. We will not go over these actions in this video, but if you are interested in diving deeper, you can find more information in the Line Database manual. Next, we'll go to the line browser to create models of our example line. Use the Correct button to add a new single-phase, two-phase, or three-phase line. We'll enter in attributes for the new line, naming it, specifying the line KV, and specifying the starting and ending substations. If you use the ASPEN one-liner program for fault studies, you should consider using matching substation names and one-liner network model bus names to enable direct line impedance transfer from the line database to the one-liner network model. You can also create any number of custom line attributes. Please see the Customizing and Querying the Line Database tutorial for more details. Clicking OK opens the line data form, the primary workspace for a line. A transmission line can have any number of homogeneous sections. To add a new line section, click on the Add Section icon in the toolbar. A line section can be one of overhead, underground, or impedance sections. First, we'll add the 10-mile overhead section in the shared corridor. This opens an overhead section placement dialog. Choose the corridor where the new line section is located. We'll select the overhead structure we just created in the ZBR corridor. If the line section does not use the entire construction span, you can specify the start and end point of the overhead line section as a distance from the beginning of the corridor. In our example, we will use the entire construction span and will not edit the values provided here. This will bring you to the overhead line section data form. Give the section a name. A cross-section display of the corridor at the section starting point is shown in the panel on the left. You must associate a circuit in this diagram with our line section. A circuit that is colored gray is already associated with a different line segment and cannot be connected. Select a circuit that is not gray and click on the Connected checkbox. Here, you can change the conductor type from the overhead default to the type being used in this section. You can edit various attributes of this circuit. Enter the earth resistivity that is appropriate for the soil type at the location of this overhead line section in the corridor. Once you are done, save the changes and close the section data form. Next, we'll repeat the same steps to create the 30-mile overhead section in the corridor we created previously. Since this is a 30-mile section within the corridor, we'll specify the start point as 0 and the end point as 30. The settings for this section will be the same as the previous line. Finally, we will add the last 5-mile section of underground cable. The underground cable starts at 30 miles from the beginning of the corridor and ends at 35 miles. Select from the library the cable type being used. Enter the placement geometry for each phase of the cable circuit. Keep in mind that Y at 0 represents ground level and Y increases as the cable is buried deeper. Select the sheath bonding option for this section. Finally, specify if the 3 phases cables in this underground circuit are transposed at regular intervals. Click OK to add the new line. Now you have completed all the steps necessary to model our example line in the ASPEN Line Database program. Next, we'll go over how to create reports of line impedance, charging admittance, and mutual coupling impedance for the line model you just created. Line constants are computed and displayed automatically in the line data form. There are also several commands that you can execute to generate different types of line constants reports when desired. You can use these results in network models for short circuit and load flow studies. The bottom panel of the line data form always shows positive and zero sequence impedance of the selected line section and of the entire line. If the line overhead sections are located in the same corridor with other overhead lines, zero sequence mutual impedance between lines is also displayed. Use the Line Constants Report menu option to print the full report to the TTY window. Results can also be shown in sequences or matrix format. To copy data and paste into ASPEN one-liner, use the Copy Line Impedance or Copy Mutual Coupling menu buttons. To create line constants reports for multiple lines, press and hold the Control key on your keyboard to select multiple lines. Then click on the Line Constants Report button in the browser toolbar. You can also export all line impedance in ASPEN one-liner DXT file format. This file can be used to create or update the one-liner network model. You have just seen a quick overview of the key steps for modeling a transmission line and creating line constants reports in the ASPEN Line Database. From here, you should have all the basics to model your own line. To learn more about Line Database components and features, please see our other tutorials or refer to the manual. We hope you have found this video useful. Thanks for watching.